Hello and welcome back to Chopstick Maths. In this video, we'll be solving sum from exercise 1, question 5, sub-question 6. Prove that 1 by root 2 plus I by root 2 the whole raised to 4 by 3 plus 1 by root 2 minus I by root 2 the whole raised to 4 by 3 is equal to 1. Now the left hand side of this has two complex numbers, 1 by root 2 plus I by root 2 the whole raised to 4 by 3 and 1 by root 2 minus I by root 2 the whole raised to 4 by 3. So this expansion has to be carried out using De Mor's theorem, and before that we'll have to convert both the complex numbers into the polar forms. So let us first consider 1 by root 2 plus I by root 2 and let us call it Z1. Let us represent this on the Argand's diagram. P is the point which is the location of the number 1 by root 2 plus I by root 2. Now the real part is 1 by root 2 and the imaginary part is 1 by root 2. So both the real and the imaginary part are positive, hence the number lies in quadrant 1. OP is the magnitude of the complex number and theta is its argument. So let us calculate the magnitude of the complex number. So r is equal to root of x square plus y square. So let us substitute x, which is 1 by root 2, and y, which is 1 by root 2, in the formula for r is equal to x under root x square plus y square. So r is equal to 1 by root 2 the whole square plus 1 by root 2 the whole square. So we get r is equal to under root 1 by 2 plus 1 by 2. Therefore r is equal to 1. So we have calculated the magnitude, which is equal to 1. Now let us calculate the argument. Now the argument theta of the complex number is positive as the angle is moving in the anticlockwise direction, and x is 1 by root 2 and y is 1 by root 2. So let us substitute this in the formula for argument. So theta is tan inverse y by x, that is theta is tan inverse 1 by root 2 upon 1 by root 2. So that is theta is equal to tan inverse 1, that is theta is 45 degrees or pi by 4 radian. Now we have calculated the magnitude of the complex number 1 and the argument of the complex number pi by 4 radian. So let us write the number in the polar form. So the number in the polar form Z1 is equal to cos pi by 4 plus I sin pi by 4. But Z1 is 1 by root 2 plus I by root 2. So that will be equal to cos pi by 4 plus I sin pi by 4. Now raising both the sides to the power 4 by 3, we get 1 by root 2 plus I by root 2 raised to 4 by 3, that is equal to cos pi by 4 plus I sin pi by 4 raised to 4 by 3. Now using De Mor's theorem, we can expand this and get cos 4 pi upon 3 by 4 plus I sin 4 pi upon 3 by 4. 4 and 4 would cancel out and we would get cos pi by 3 plus I sin pi by 3. Therefore 1 by root 2 plus 1 by root 2i the whole raised to 4 by 3 is equal to cos pi by 3 plus I sin pi by 3, and let us call this equal to 1. Now let us call this complex number 1 by root 2 minus I by root 2 as Z2. So Z2 is equal to 1 by root 2 minus I by root 2. Now let us represent this complex number Z2 on the Argand's diagram. Let P be the point which is the location of the complex number 1 by root 2 minus I by root 2. Now x is 1 by root 2 that is the real part, and the imaginary part is minus 1 by root 2. OP is the magnitude of the complex number and alpha is the argument of the complex number. Alpha would be negative as the angle is moving in the clockwise direction. So let us calculate the magnitude. R is equal to under root 1 by root 2 square plus minus 1 by root 2 square, which is R is equal to under root 1 by 2 plus 1 by 2. So R is equal to 1. So we have calculated the magnitude, that is equal to 1. Now let us calculate the argument alpha. Alpha is tan inverse y by x. X is 1 by root 2, y is negative 1 by root 2. But here in alpha, I have substituted x and y as positive. So alpha is tan inverse 1 by root 2 upon 1 by root 2. Alpha is equal to tan inverse 1, so alpha is 45. Since I have substituted y, which is 1 by root 2, as positive, y has been substituted as positive, so I am getting the angle positive. However, alpha is moving in the anti-clockwise direction, so alpha is negative. So theta is equal to minus alpha, so theta is minus pi by 4. Now, we have calculated the magnitude r is equal to 1 and the argument theta is equal to minus pi by 4. So let us represent the number z2 in the polar form. Now z2 in the polar form is 1 by root 2 minus I by root 2 is equal to cos minus pi by 4 plus I sin minus pi by 4. Now raising both the sides to the power 4 by 3. 1 by root 2 minus 1 by root 2i the whole raised to 4 by 3 is equal to cos pi by 4 minus I sin pi by 4 the whole raised to 4 by 3. Now cos of minus pi by 4, that is cos of minus theta is cos theta. So cos of minus pi by 4 is cos pi by 4. Sine of minus theta is minus sine theta. So sine of minus pi by 4 is minus sine pi by 4. So this becomes negative. This sign becomes negative because the negative sign comes out. So that is cos pi by 4 minus I sin pi by 4 raised to 4 by 3. Now expanding this, we make use of the De Mor's theorem. So applying De Mor's theorem, we get cos 4 into pi upon 3 into 4 minus I sin 4 into pi upon 3 into 4. 4 and 4 would cancel out and we would get 1 by root 2 minus 1 by root 2i the whole raised to 4 by 3 is cos pi by 3 minus I sin pi by 3, which we can call this as 2. Now adding both the complex numbers, we get the left hand side. 1 by root 2 plus 1 by root 2i raised to 4 by 3 plus 1 by root 2 minus 1 by root 2i the whole raised to 4 by 3. That will be equal to, this is what we had calculated. Now this number is cos pi by 3 plus I sin pi by 3 in the polar form, and this number is cos pi by 3 minus I sin pi by 3 in the polar form. So after opening the brackets, we see that the imaginary part cancels out and cos pi by 3 plus cos pi by 3 will give us 2 cos pi by 3, that is 2 into cos pi by 3 is 1 by 2. 2 and 2 would cancel and the final answer will be 1, that is equal to the right hand side. Thank you very much for listening.